Kia ora Year 12 and 13. This is the first video that I'm doing on last year's integration paper. I've split the paper up into 6 parts, so this part will just go through A, B and C in question 1. So that's 2 achieved questions and a merit question, so it shouldn't be too bad. Right, have a go at this before I go through it. We can write that integral. Oh, where's my pen? Just a sec. Okay, so we can write that integral as x to the power of a half plus 6 cos 2x dx. Right, so integrating each bit in turn, the first part will be something times x to the power of 3 over 2. So I've got to take a look at what I want to have sitting here so that when I differentiate I end up with an invisible number 1, and of course that's going to be 2/3. So that means that when I pull down the 3 over 2, I times it by 2/3 and I get the missing invisible 1 over here. So that's the easy bit. Next bit is a trig function. So what will integrate from cosine? Well, it'll be something to do with sine of 2x. Okay, because sine differentiates to give me cosine. Now just looking at this one, if I differentiate sine of 2x, that'll be 2 cos of 2x. I want 6 cos of 2x. So the number in here needs to be a 3. And we need our constant of integration. So 2/3 of x to the power of 3 over 2 plus 3 sine 2x plus c. If you're in my class, you know that I would much rather write it back like that, but because we're talking about exam conditions, don't do that. Okay, just leave it how it is and move on to the next question because you won't have time. Okay, on to part B. Right, so this is a differential equation. Well, it sort of looks like a differential equation. So dy by dx equals 2x. Solve this dE. Given that when x equals 1, y equals 3. Really, this is just another way of writing Year 12 problem, right? Which is that f dash of x is equal to 2 over x, and f of 1 is equal to 3. So, of course, when we were doing these in Year 12, we didn't think of them as differential equations, but now that we've got through integration, we know that they are. So all I'm going to do is anti-differentiate 2 over x and see what I get. So that will be 2 log of x plus c. Now I'm going to work out what my plus c is by saying when x is 1, y is 3. So we get 3 equals 2 times the log of 1, right? I don't need my absolute value signs now, by the way, because 1 is greater than 0, so they are redundant, plus c. But we know that the log of 1 is 0, so here I get 3 equals 0 plus c, so c is just 3. So my solution is y is equal to 2 log of x plus 3. Now if you're in my class and you're watching this in week 1 of term 3, we haven't actually thought about differential equations at all yet, but hopefully you can take a look at this question anyway and just see that it's nothing scary about it at all, right? It's just a problem that we've already done with some slightly different language, which is this language here. Okay, so my answer here is our equation y equals 2 log of x plus 3. In other words, I've used this piece of information to get rid of my constant of integration and pin down which member of the family of 2 log x plus something we're working with. Okay, on to the last part. Okay, so this is another differential equation, and this is one that we won't be looking at for another week or two. We use a technique here called separating variables. I'm going to assume that we've done that now. So what we do is we kind of think of our dy and our dx as being able to be separated, and we write the equation like this. Dy 4y, which looks a bit silly, is equal to dx times e to the 2x. Right, now that's a really strange way to write it because usually we put our dy and our dx at the end, so we'll do that. Now we've got 4y dy is equal to e to the 2x dx. Those two things are the same, so I can anti-differentiate both sides and they will still be the same. So that's the basic idea behind separating variables. So just look at each side and anti-differentiate. Right, doing the left-hand side first, we're going to get 2y squared. And on this side, we're going to get, well, if we want to end up with e to the power of 2x, that's going to have come from 1/2 e to the 2x. Okay, now we don't need to have two plus c's. We don't need a plus c1 and a plus c2. We're just going to have a kind of gather it all together plus c. So that's where I've got to. And now what I've got to do is use the next bit of information to get my plus c worked out. So we know that y is equal to 4 when x is equal to 0. So that means 2 times, substituting in, 4 squared is equal to 1/2 e to the 0 plus c. So 32 is equal to 1/2 plus c. C is equal to 31.5. But of course we are going to write that as c is equal to, what's that work out to be, 63 over 2. So I'm going to turn to a new slide now. Remember that our goal is to figure out the value of y when x equals 2. So where we're trying to get to with this problem is to get an equation that doesn't have the plus c, and then we're going to solve for y when x is equal to 2. Right, so we've figured out our constant of integration, and we get 2y squared is equal to 1/2 e to the 2x plus 63 over 2. So the last thing we've got to do is to say, what is y when x is 2? So we substitute in 2y squared is equal to 1/2 e to the power of 4 plus 63 over 2. So that gives us 2y squared is equal to approximately 58.8, just doing that on your calculator. So y squared is half of that, 29.4, and so y is going to be equal to 5.42. Okay, that's all for this one. I'll do another video with parts D and E shortly. Thanks for watching.